Okay, so I think we have gone up to.
Yeah. Will you show the index today?
Yeah, I will show you the indexes. Okay, let me go to my screen. Actually, okay. See here. So if you open a table, this is. If you open a table, you will see all these tabs. They have columns, data. Data means like your rows, okay, and then data model. I think sometimes it will open or it won't open. Constraints. So in the see all the constraints like primary key, okay. So if you create a primary key on the table, you will know by looking at the constraint. So you can see the constraint type is a primary key, and this is the name of the constraint. So you can see like who generated it, what was the last change on the table, okay, all those things. You can see statistics basically, okay, and then see the check constraint, okay. What are they checking here? ID field is not null, okay. So that means it will always check. It will always make sure that ID is not entered as null, okay. Type field is not entered as null, okay. These are all columns, ID and top. See, ID and type, these are all columns, okay. So it will make sure that none of these are null. And then see the another different type of check constraint. It has type in S comma C. Type, this is the field, okay. The type field, it is not null. So the one column has two different types of constraints. One is type is not null. Another constraint is type will only have values either S or C, okay. So if you look at the data, it will only have either value S or C. See, some of the C's are there here, and then there won't be any nulls. So that is how that is why you create the constraint. Okay, that's it. So those are the constraints here. Let me see if I can find any indexes. There should be a big table. What? So foreign key, foreign key, foreign key. Okay. primary key and two foreign keys. Two foreign keys means it has a relation with the two other tables. Okay, let me see if I can open a data model. See, this is the data model. This is how the data model looks like. Okay, the table I open is in Telcare schema dot app hierarchy. The table name is app hierarchy. Okay, and then it has a relation. The table is integrated with two other tables. One is application table, and another one is actually, yeah, it only has one link. Okay, okay, let's see. So it only has one link. Let's go back to construct app foreign key 2. Okay, both the foreign keys are connecting to application table. This is how you can see the schema name and the table name. So both the foreign keys are connecting to application table. Okay, so that means it could have two foreign keys. That means it could have multiple foreign keys for the other table. Okay, so the application table has same thing. It has foreign keys with two other different tables, or it could be one different table. Okay, but it also has two foreign keys. Okay, so let's see what are the foreign keys. One foreign key is parent app ID, another foreign key is app ID. Okay, let's go back to application table. So app ID is the primary key in this table, right? Okay, and let's see where is the parent app ID. Parent. P. App ID. Yeah, I can see it because it has too many columns. I don't know where the parent app ID is, but it should be there. That's fine. Let's go right up here.
Parent app ID.
Select parent app ID from application.
From you type the node.
Oh, okay. Parent app ID invalid identifier, so it doesn't have that field. So I don't know where is it linking to. Foreign key, parent app ID, hierarchy. Okay, let's go back to constraint and see if it tells anything. Yeah, it doesn't have that field. Okay, that's okay. Anyway, so this is how the foreign keys are defined. Okay, I don't want to waste the time. So this is how the foreign keys are defined, and this is how the data model looks like. We still have to find the indexes if there is anything. Oh wow, actually I'm looking in the wrong place. Okay, the indexes tab will show you the indexes. Okay, not the constraints tab. See, these are the indexes, and that is how they look like. The app instance table. So there is one table. It has indexes. Okay, so you can create an indexes on the primary key also. Okay, so in the Telcare table, the app instance table, service number ID is the primary key. I can go to constraints and show you. Okay, so see the primary key column. Okay, it's here we can see, sorry, here service number ID is the primary key for this table. Okay, got it, guys?
Yes, sir.
Okay, so service number ID column is the primary key for the app instance table. Okay, if you go back to indexes, what happened is they created a unique index. How many types of indexes we were talking about? Unique index and non-unique index. Okay,
Yeah.
so only two types of indexes are there. Okay, yeah, only two types of indexes are there, unique and non-unique. So unique index is there on the primary key. So if you want to create a unique index, you have to select a field that is not null and also a unique. Okay, so that is why then only you can select unique index on those tables, and then the non-unique indexes. Okay, on these columns. Let's see what are those fields. Okay, so as I told you, for one index you can select multiple columns. Okay, so here you see for this one non-unique index they selected like for 4 fields: app ID, service code, service number, and service start. But combined together they are one index, non-unique, but one index. So that means it could have duplicates also with these 4 columns. Okay, there could be a same app ID, same service code, same service number, and same service start date multiple times. It doesn't matter. Okay, because they're not unique. Same thing for the second index. Let's see what are the columns: service number and service code. They could be also same, but they are under one non-unique index. Okay, you can also see the column names here also. What are the column names you are adding it to the index? You can see here also. Okay, so yeah, these are the simple examples for the indexes. So the indexes are added to a table because you wanted to search, you wanted to look up faster. Okay, these will help looking up the data faster, so that your queries run faster, because these are very huge tables actually. I can show you statistics and then see the data. So see, it has around number of rows almost 10 million, or maybe more than that. Yeah, it has 10 million rows. Okay, so that's it. So any questions?
No, sir.
Okay. Okay, auto increment. Auto increment, same thing. We talked about the auto increment for micro identity, right?
Yes, sir.
For Oracle, sequence is an auto increment. Okay, let's go and see. So okay, MySQL uses auto increment here for MySQL database. So MySQL is a different database. Okay, so this database uses the word auto increment directly. Auto increment, and that is the function it uses to increment the row or the IDs or any other numbers. If they want to increment a number, auto generated number, you can use that function in MySQL database. But for in SQL Server, see identity. Okay, create table. When you are creating a table, you can add any column name. This could be anything: name, integer, identity. That means you are starting with 1 and incrementing with 1.
Yeah.
and this is also a primary key for the table. Okay,
Yes, sir.
let's go to insert into. Insert into person first name last name. Okay, syntax for access. For access also it's auto increment but without underscore. There is no underscore. For MySQL there was an underscore, but here there is no underscore. That is the difference. Okay.
Yeah.
Uh,
And we can't
for-
give, I'm sorry, we can't give the incremented value like this, right? In MySQL and MS Access. We
yeah,
can't
they
pass
are
any
not
parameters.
giving. Yeah, I don't see the parameters. I don't know why. Okay, here see.
Yeah.
Alter table, then to let the auto increment sequence start with another value, I think it by default it will start with 1 and increment by 1.
Yeah.
Okay, by default you don't need to do anything. In the database it is set up as that, but if you want to change that parameter, so you have to use this alter table person, the table name auto increment is equals to 100. Okay,
Yes, sir.
so that means it will start from the 100.
Yeah.
Okay, so same thing for the access also. It starts with the 1 and then increment by 1. Okay, so let's see if there is any increment. Same thing for Oracle. Okay, so when you are inserting any data into the table, let's take persons table. If you are inserting any data into the table, you don't need to worry about the auto increment column, because whenever you insert a row, it will increment by 1 and then automatically insert that value into the table. Okay, so you don't need to add that when you are creating an insert into query. Okay, see, there is no ID column here because it will automatically increment. Okay, this is for this syntax is for access. Let's see here. Okay, simple. So if you want to specify, start with 10 and increment by 5, you can add like this: identity, 10, 5, and then same thing. You don't need to add that ID column or auto increment column in the insert query. Okay, because it is system generated, it will add automatically. Okay, syntax for Oracle, as I told you, the Oracle uses sequence create. So, but for this, in the Microsoft SQL Server, the identity is a function. It's an inbuilt function. You can specify the values, the increment value and the start value. But for the Oracle, you have to create your own sequence every time you want to use that sequence. You have to create. First of all, you have to create a sequence in the Oracle. Okay. You will have to create an auto increment field with a sequence object. The name is sequence. Okay. Let's see here. Its syntax is very simple to create a sequence. So create sequence. The sequence name, you can give any name. Minimum value 1, starts with 1, increment by 1, cache 10. Cache is nothing but the memory, how many digits or up to how many digits you want to save in the memory. So that is the cache. You have to specify the cache because that is 10 numbers is the max you use for the auto increment. Okay, you can use more cache. When you can use cache more, like you can give 100 also, but 10 is the normally people use 10. Okay, in the cache. Cache is nothing but memory. Okay. So you understand, right? Minimum value is 1, max starts with 1, increment by 1. Okay. You can also give max value, like the min value. There is a max value that will limit. So once the auto increment reaches that max value, it will just the insert process will fail. Okay, because it reached that max number. Because they didn't give any max number here, so there is no limit for that number, auto increment number. Okay.
Yes.
So I see here it will also cache up to 10 values for performance. The cache option specifies how many sequence values will be stored in memory for faster access. Okay. same thing, but the syntax when you are inserting into the table, the syntax is little different here. Okay, see, insert into a person's table, you have to give the column name here. None of the other databases you don't need to give a column name, but for Oracle you have to give the column name, first name and last name, and then in the value section you have to give the sequence which you already created, and then you have to give dot next val. Okay, sequence dot next val. I will show you an example also, but when you are inserting, this is the sequence name you just created here. See, sequence underscore person is the sequence name. You are using dot next val, comma, first name, comma, column name. Okay, so I will show you. I have created recently a sequence. Let's go. Okay, so there is a different. So for the tables, there is one section, different section. Okay, for sequences there is different section. For procedures there is different section. Functions there is different section. Okay, so Oracle is like that. SQL Server is little different than Oracle. Structure and metadata wise, how the metadata is stored, the background process is little different. Architecture is different. Okay,
Yes.
so sequences. In the sequences, there's no sequences. I think maybe let me go to different database. Okay, here sequences. Okay, see here, this is the stat sequence. This is what I have created just recently. Let me open the syntax for you. See, create name, create sequence, name of the sequence. I've given start sequence. My minimum value 1, max value. See, I've given 999 like that. You can give anything. Okay, this was my max value. Increment by 1. Start with. So I have started with 1, but what happened is that currently in the table there are 190,000 rows. Okay, and then cache is 20. The cache I have selected 20 because the max val I have given is 20 characters, 20 bytes. Okay, the max value is 20 characters or 20 bytes. That's why I have given the cache as 20. Okay, and then it actually started with 1, but right now there are these many rows. But whenever the next row is inserted, it will start from 9898. Okay, whenever the next row is inserted, the value will be the value will start from 190988. Okay, details, same thing. It is the same thing that we have seen. Okay, there is no dependencies or anything. Okay, so I will show you where I'm using the sequence value. Okay, okay, this is where I'm using that sequence in the UTL stat table. Go to data, see this number, the stat sequence.
Yeah.
So that is where whenever the new row is inserted, the value changes. Okay, let me go to the max number. So it is 190,000 or something, right? Okay, I don't want to go. So you understand the concepts, right?
Yes.
So this was the sequence value that is basically increment every time, 52, 53, 54. Every time the new row is inserted, it will increment. Because, you know, this is the best example in the table I'm showing you why we need a sequence. Okay, because this table here, what data I'm storing is job name, job, when the job was started. So this is the ETL job, my data state job. Okay, when the job was started, when the job was ended, how many rows are inserted into the target table, how many rows are updated, deleted, okay, extracted, what is the job status, created date, created by, updated date, and so the files, because these jobs, they get the data from the file. So I'm also saving the file header and the file trailer, okay, also the sequence number in the file, and then the project name. So basically all this data, and the file name, you see the file name here, right? I'm storing all this information. I'm storing all this information here. Just 1 second. Okay, so I'm storing all this information here. I don't have any primary key column, right? You guys understand? Do you see anything that can make as a primary key here? This is just a static data. There's no primary key value, right? So that is why, because there is no primary key, I can't use any column as a primary key. I'm using this field. I'm using the sequences as a primary key. Okay? As a unique. If I want to find any unique value, I can use the sequence column. That is what I'm using. Okay? So that is done. Any questions on the sequence?
No, sir.
Okay. So we have covered index, auto increment, and the views. Okay. Okay, views. What is the difference between the tables and views? Do you guys know?
View is created from the table. It's not a table actually. It's just a view.
Yeah, exactly. Good. So basically, view is nothing but it will get the data from a table. It could be a one table or multiple tables. Okay. So if you want to combine multiple tables and then put the data in one table, okay. But what will happen is, if you do that, basically if you get the data from multiple tables and then join the tables and then put the output in one table, okay. But what will happen? The table won't be updated every time, right? It is just one time, right? But if you want the data to be updated every time you access the table, that is when you can use the views, okay? So views, basically, if you create a view and from the multiple tables, okay, what will happen is, every time you access the view, the data will be refreshed. That means the new data will be added to the table, view. Okay?
Yes, yes.
Yeah. So in a SQL, a view is a virtual table based on the result set of a SQL statement, right? So the view in the background, what is the background of the view is basically a SQL, okay? I'll show you. We have the views also here. I can show you sequences, materialized views. Okay. So there is no materialized views. Let me show you the views. Okay. So see, these are called views. Okay. The symbol is different for the view. Symbol is different for the table. The symbol is different. Okay. Okay. Let me open one view. If you go to the data, see, it's refreshing. Okay. Anyway, so if I go to the SQL, it's basically a DDL. Okay. So SQL, create or replace view, name of the view, and the columns. Okay. See the columns. See, all the columns are selected. Okay.
Yeah.
Given in but as. Okay. they're using as in create the SQL for the view. See, inside the create or replace view, there is another select statement. Okay, select from this table and the where condition. So basically that whole select statement created as a view. So all these column names like run date, see the run date is here, row number is here. Okay, so basically this select statement was just created as a view. Okay, understand what is the view now?
Yes, sir.
Okay, the view, you can basically select data from one table. You can also select data from multiple tables. Okay, so see this one, it has different multiple queries. Okay, it is selecting this, but there is the inner query, it is selecting something and it's doing union on multiple other queries. Okay, see how big is the view? Yeah. Okay, but at the end of the day, all these columns are selected. Same thing, the whatever the columns are created here, they are selected as a view. Okay, if you go to columns, the same columns will be there here. If you go to data, the data exactly look like a table. Okay, there is no difference. The data looks like a however the data looks like in the table. Okay, so that is the view. So creating a view is very simple if you know what you are trying to do. This is the simple syntax: create view, view name as, same thing. You can select the column names from the table name, and if you have any where conditions, you can give. Okay. So view example: create view, view name as, then the select query. Okay, so simple. Create view, view name as, then whatever the query you want to give here. Any questions?
No.
Okay. Okay. So by looking at the actual view, it is easy to understand, right? Okay. So same thing as I showed, other views, simple. You can add anything under the view, and then you can use that as a view. Okay. You can use any SQL. Okay. Injection. I don't know what is injection. I have never used, but let's see what this is. SQL injection is a code injection technique that might destroy your database. We don't need to know this, okay? We really don't need to know this.
Hacking is...
Hmm?
People use it for hacking, hack the data.
Yeah, hacking. Otherwise, you can use that. Looks like you can use the code in HTML. See this thing here. So looks like you can use this in a HTML, like in your websites or something. You can use that. So if there is nothing to prevent users from entering wrong input, that the user can either some smart input like this, then SQL statement will look like this. Anyway, yeah, that looks like something be used for like a HTML code, inside the HTML code, okay? Or a hacker might get access to all the username and passwords in database by simply inserting 105 or 1 is equal to 1 into the input field. So basically the SQL injection, see, like where you enter your username and password when you log into your details. So yeah, behind those in the HTML code or in any Java code or something, this SQL injection will be used. Okay, that is what my understanding is. SQL hosting, same thing. This is also looks like you can use it for inside the websites. Okay, we don't need to know that also. Okay, let's go to functions. Okay, So since you guys already have some idea of SQL Server, I'll show you some SQL Server functions and Oracle functions and how they can be used in the queries. Okay. Just give me 1 second. Okay. Okay. So what function do you guys know in SQL Server?
Some of the date functions like get date, next date and
Okay.
get diff,
Okay.
and also the minimum maximum, the arithmetic functions you can use,
Okay.
default functions.
Okay. Okay. Parmesh, do you know any functions?
No, bro, I don't know. I didn't use it.
Okay. Okay. So Oracle string functions. Okay. Okay, we have. I'll show you. Okay. Concatenation. Okay. Do you guys know what is concatenation?
Yes. Writing
Okay.
side by side, right? Putting the side by side.
Yeah. Okay. So I have something. Okay. Name. Right. Parmesh.
Yes, bro.
Okay. See, do you guys know pipe mean? What pipe is? Parmesh, do you know what pipe is?
So,
Pipe.
In the keyboard, pipe.
No. Oh, the
See?
one. Okay, that symbol, right?
Yeah, that's a pipe
Right.
symbol. See this? You know that, right? And the keyboard. If you look at your laptop keyboard, there is a pipe symbol. Okay.
Yeah.
Okay. So if you enter that 2 times, okay,
Okay.
this is a concatenation function in the database, in Oracle database. Okay. So see the output. Select. Okay. So before I even start this, I want you guys to know dual. Do you know what is dual in Oracle?
no, sir.
What?
No. Okay. Dual. DUAL.
Oh, no. Don't.
Okay. Okay. Dual. So dual is simple. Dual is actually a temporary table in the Oracle database. Okay.
Okay.
So let's go to, I don't know what day we are reading this. Is this a day 5? Anyway, so whatever the topics we covered, I'll write it here. SQL. I want to say dual. Okay, dual is a Oracle thing. Okay. Okay, let's show you what dual is. Select name from dual. Dual is a temporary table. It is a table, but you can't even see where the table is. You can't find where the table is. But whenever you write something like this, select name from dual. Okay, let's say dual as a table. If you run this query, okay, maybe not like in the double quotes, but okay, let's see. What? Okay, so what do you see now?
Name column.
Yeah, name as the column, name as a value. Okay, so what is it doing is basically whatever you are giving, and then when you because the dual table is used for testing purposes. Okay, it is a temporary table. You can use that as a testing. Okay, you can use that for testing. So let me write something else. Select select sysdate. Sysdate is a system date, like a get date in SQL Server. Sysdate is a Oracle date. Okay, Oracle date function. From select sysdate from dual. When I run that, what are you getting here in the sysdate?
The today's date.
Today's date. Okay. So if you want to see how the value will be, you can use the dual table. Okay, you can use the dual table for testing anything. Okay, let's see. Okay, I want to give the value a column name. Okay, see, I'm giving the column name as X, but the value is name. So you want to see, okay, when I create a ETL process, I just want to know how the output looks like. Okay, you can use the dual table for that purposes. Okay, if you run it, what you got here? X as the column name, name is the value. Okay, so anything. Okay, so I want to know what is the yesterday's date. Okay, so you can use like this, sysdate -1 from dual. So it will show you yesterday's date. Okay, so basically, so the main purpose of the dual is for testing. You want to see how the output looks like. You can use the dual function. Okay. Okay, so that is good. So why I'm showing that is because if I want to show you how the functions work, you have to know the dual table. Otherwise, you don't understand what I'm doing. Okay, so the first thing I'm showing you is the concatenate function. Okay, let's go back to the word functions. Okay, concatenate, 2 pipes is the concatenate symbol. Okay, so first name, concatenate, last name. How do you see the output? You have to use the dual from dual table. Okay, when you run,
it was single quote.
Yeah. Single quotes I have to use. Okay, what happened? Ramesh, what happened here? Exactly. Two things are combined. So basically concatenation is nothing but combining. Okay. So this is there is no space between. It looks very bad, right? So you can add space here in the second one or the first one. So inside the quotes, just add a space. So and then run it. What happened? There is a space. Okay. If not, you can add a space here after the F name and then run. So basically you have the name, space and the last name. Okay, so that is how you use the concatenate function. Another example is select. I am going to use sysdate. I don't need, because it's a function, sysdate is a function, inbuilt function. I don't need quotes for that. I want to try use sysdate and then sys timestamp. Okay, let's see what happens if I run. See, you have the date here. Oh, actually the timestamp means it is actually complete thing, date and the timestamp. Okay, when you run, you have the date and the timestamp. Okay, the timestamp is in milliseconds. That is why you see like all the other numbers after the seconds. There are so many seconds. It's milliseconds and then AM, PM. Okay. Okay, so that is how you use the concatenate function, dual and sysdate and systimestamp. Okay, sysdate. This is the date. Okay, so sysdate and timestamp, indexes. What are the other things we completed today?
Views.
Auto increment and views. Okay. Auto increment, views. Okay. What is the next thing we have to see? Okay. These are just standard things. ASCII returns the number code that represents a specified character. ASCII is like standardization. Okay. See ASCII. There are so many other types. Okay. Okay. Whatever the important, I'm going to only explain those. So let's say concatenation is important, and then convert. Converts a string from one character set to another character set. Okay. So convert is also a little bit important. Convert Oracle example. Okay, so see, he's also using dual table because he wanted to give you an example. Okay, you have these special characters, right? Do you guys know these special characters? They are like European characters, A, E, I, O, and then this is also a different type of O. Do you guys know that?
Yes, yes.
Okay, so they are European characters. So their standard is this one, US7 ASCII. Okay. And then this convert function is converting them to this type of standardization, WE something. Okay. These are basically character sets. Okay. So here, so when they use that function, you can see the output in Oracle. See what happens. All the above letter A there is something, above letter E there is something. So all those are gone. Now they are converted as a normal characters. A, E, I, question mark, A, B, C, D, E. Okay. So this character set belongs to these letters, and then they is converted to this character set. Now the letters look like this. Okay. So that when you want to do some conversion between the character sets, you can use the convert function. Okay. And then let's see, there are so many types of character sets, not only one, but I think you have an idea. You should have an idea of UTF-8. You guys know? You guys remember the UTF-8?
Yeah.
If you guys have a basic programming idea, UTF-8 is even in your laptop. You can see when you convert your disk space, the UTF-8 and UTF-32 are used. Okay. So these are all convert encoding. You can call them encoding. You can call them convert character sets. Okay.
Yes.
Not only these, but these are common character sets. There are so many character sets out there right now. Okay. You can query this to view the listing of valid character sets. Okay. Let's try this one in our database. What happens? We will show you the character sets that the database is using, I think. See? UCS7, these are all character sets. There will be one character set is true. I think that is what the database is following right now. So many there. I think looks like there are other databases. They have that as true also. Okay. See, 247 character sets. Anyway, so this is just for the basic idea. If you know this, that is good. So today, once the class is done, go through those character sets. Okay. So see, convert. It converts from a string sorry, one character set to another character set. Okay. Okay, length returns the length of the specified string. Okay. Yeah, convert LENG. I'm going to move these to length, right? Okay. So length should be simple. I'll show you what length is. If you want to find out the length of a column, you can do that. Select. LENGTH of first name from Dual. Okay, how many characters length of the first name? 5. So you give anything here, it will give you the. Okay, so there are values like this in your table, and then you want to know what is the max character in your table, okay, in one column. So you can give the column name here and then run the query. So let's see if I have this, right? And then it will show you 31 characters. Okay, so same thing, you can use that in the table also. I will show you one table. So I have this table, right? Let's drop that here. Okay, now I have the table name. Let me take one column, which so this is a 50 byte. Okay, map description, column name, and then run. Table view does not exist. Oh, okay, sorry. We have the dual there, that's why. Okay, see, for every column it is showing you the length. Okay, I can also do max of length of that. See, 9 characters is the max in the table. So that is how you use the function. Got it?
Yes, sir.
So we use max and the length. Okay, it should be minimum also should be simple. I will show you the minimum function on my end on the table. So minimum is 3 characters. Okay. Minimum length of that column is 3 characters in the table. Okay, good. So we got covered all those things. Okay. So anyway, so tomorrow also I will go through some more functions like replace, regular expressions, and all those trim function, upper function, lower function, substring function, which is important. Okay. So tomorrow, let's go through Oracle, some Oracle functions and some SQL Server functions. Okay.
Okay.
And then yeah, I think we can go through these also in a couple of days. Then once we are done, we can start. Okay. Did you guys get a chance to install the Ubuntu server?
Yes,
Yes,
sir.
yes.
I've installed it.
Oh, you did?
Yeah.
Yes.
Oh, okay. Both install it?
Yes.
Yes, sir.
Oh, okay, good. That's good. So we can just finish the Unix in 2 days. No, I don't think much time is needed for the basic Unix. Yeah, 2 days should be good enough. Okay, guys. So see you tomorrow. Okay, I'll text you the time. Okay.
Yes.
Okay. Bye.
Bye.